everybody hear me in the back? Pretty good? Good. All right. Welcome to the Embedded Systems Product Roadmap, Product Outlook. I am Kirby, Senior Product Manager on the Data and Control team here tonight. I specifically focus on C-Series, but today you're going to hear about everything in the embedded platform. I'll probably slow down in C-Series because I know about it. But we have a lot of experts here in the room. I can see them up in the front, so we can hopefully get the questions answered as well. Now, as we go, I can talk about a lot. I'm going to probably move pretty quickly. But if there's something that you see that you want to learn more about, raise your hand and let me know, and we can have a conversation about it. Because you're probably not alone. Other people probably would like to see things as well. Okay, let's get started. So, the first thing I want to get into is embedded controllers, right? So this is kind of the core of our platform. This is compact RIO, single board RIO, PXI, real-time FPGA controllers that have kind of the core basis processing to get your applications. And first we start with a reminder. Over the last few years, we've been really working hard at completely overhauling our compact RIO and single board RIO product lines. And we're done. We can finish that officially. And along that, we have increased performance by at least 4x across the board. We've brought in a brand new, open and extensible operating system based on Linux and Linux real-time. And we have drastically improved the FPGA performance. In most places, we've increased FPGA performance by well over 4x across the board, as well as DSP slices and other capabilities. So we've really been working hard on this. We hope this is a foundation for a lot of new embedded opportunities and applications in the future. Now, I said we're done, but we decided to cap it off with one new controller. We're bringing Wi-Fi to compact RIO performance product group specifically. You can see what they look like here. Here's some more information on the specifications. If you're familiar with the compact RIO product line, these are kind of the mid-grade specifications of the performance atom controllers. But you replace the SD card and user button with an 802.11n dual-band Wi-Fi radio. It's a by-2 MIMO as well. And so one of the questions you're probably wondering, and I've had a couple of last minutes already, why would I do this instead of just buying a Wi-Fi gateway, putting it next to my compact RIO? Which is a fair question. Besides the fact that you don't lose an Ethernet port in the process by attaching it to the gateway, doing Wi-Fi design is fairly complicated, especially for the industrial environment. What we've done here is we've attempted to build a really industrial Wi-Fi solution with long-term life cycle. We've met the different regulation requirements across the globe. We've focused on testing this in environments that are similar to other industrial applications. Guaranteed throughput and reliability in that space. Made sure that it fits our industrial temperature range, in particular negative 20 to 55, or yeah, negative 20 to 55 C. Fully integrated into the NI software experience. Of course, that's another really big part of it. So this looks just like another adapter in Measurement Automation Explorer. You can access it just like another adapter in Linux. Now, in terms of certifications, where this can be sold right now, US and Canada, EU countries, China, and Japan. And we're currently working on Korea and Taiwan. Now, if there are other regions or countries that you need or would like to have this product offered in, let us know, and we can have a conversation about that. Right? We can have a conversation. All right, good. All right, so what can we do with this? We had a lot of different ideas when we were thinking about adding this Wi-Fi capability to compact RIO. One of the first things I want to mention, you can actually set this product into an access point mode, which means you don't need any extra infrastructure. You can just bring a laptop or a cell phone and connect directly to the compact RIO now. We think this will be most useful for an HMI situation, right? So you have kind of a wireless HMI with a connection to this through Wi-Fi. The other areas are more traditional, like asset monitoring, where you could deploy these across a wide geographic area, have them communicate to some infrastructure that's been located in the area, and send their data back to a server, all wirelessly. Or if you've got a control application, for example, oil and gas is a pretty good example, where cabling is really expensive. This is a great way to cut the cord, or if nothing else, you can add a redundancy to the Ethernet that you may already have. So if that gets cut, you can fall back to something like a Wi-Fi connection, vice versa. right, any questions on the Wi-Fi before we move on? All right. So, moving on to another area of controllers, we have a new NI industrial controller family. So this is a whole range of products. These are the highest performance embedded controllers that we have, or have had, in this fanless rugged solution. They have Intel Core i7 or Intel Celeron processors. We've got large Kintex 7 FPGA, and then a wide range of peripherals. You can see the kind of setup here. 4 DB ports with PoE, great for cameras. 2 USB 3 ports, also great for cameras. As well as your standard complement of USB 2.0 for keyboards, mice, other peripherals. And then you have a complete set of I/O here through this mass termination connector that connects into the FPGA. Yes?
That's LabVIEW. That's LabVIEw FPGA I/Os.
Thank you. It's a very good clarification when I say connecting to the FPGA. It's LabVIEW FPGA programmable. If I'm not mistaken, Mark, you correct me here. You can actually use it with a built personality, so you just access the I/O if you want to, or unlock that FPGA capability and program it through LabVIEW FPGA. Good. So a couple ways that we can use this. Not just for vision. Obviously, this would be a great solution for a high-performance vision application. But if you attach an Ethernet or EtherCAT Rio chassis, you've got a complete C-series solution with a high-performance controller for processing. You can also attach EtherCAT drives for a complete motion control solution, or of course combine it all together and build a single high-performance vision, motion, and high-speed measurement application. Now, something to note, check out the dimensions here. Every time I see this, I think the image makes it look, for some reason, I think it's smaller than it really is. It's a little bigger than what you might recognize. And that's important because we're going to also release a version of this that is IP67 rated. So this is for waterproof applications. And it's the same product, right? Same performance, same capability, same I/O set, but in an IP67 enclosure. And you'll notice that in terms of dimensions, it's the same height and width, but it is deeper. I don't actually have a metric on how deep, but it is a deeper product.
50% deeper.
50% deeper. There you go. So it's significantly deeper, but still fanless and waterproof. Which is the key there. Any questions on the industrial controller? Awesome. All right. Moving on down the line. So what would pair really well with this new IP67 grade industrial controller, or just the straight up industrial controllers that we released, are a brand new set of cameras, including new smart cameras. You can see our current design here and then the new one. What's great about these is not only are they IP67 with M12, just like the old ones, but they're half the size, half the cost, and twice the performance. So improvements all the way around. Or you can connect with our new industrial cameras. These are DB, PoE, so you can connect them right to the PoE ports on this new controller. And they come with integrated lighting, integrated lens, so it's a complete solution for industrial vision. All right, now those aren't released yet, I want to note. This is coming out in early 2017, so first half of 2017. All right, so moving on from there, we're going to talk about a new area that we've been doing a lot of research in. Many of you may have already heard something about this. It's work into time-sensitive networking. And we're going to be announcing, or actually not sure if it has been announced yet or not, but we're going to be announcing an early access technology program for this new time-sensitive networking. Now what this does is allows you to take network devices like compact Rios and very specific switches, such as these Cisco switches, and implement a controlled network that has low jitter, so time synchronized, less than a microsecond. Allows you to have control loop rates over 1 kilohertz. But what's really interesting is this is a converged Ethernet network. So that means that you can run your control network, your control loops, your network communication right alongside just standard TCP/IP, UDP network communication. So you don't need a separate field bus network for your industrial devices. You can now build this all on standard Ethernet using these specific switches and hardware, such as the compact grids that we have available. Now, a couple of things about this time-sensitive networking, because there have been quite a few questions. Oh, before I go on, I seem to always forget that this animates. This is not just NI working on this, this capability. There's actually a broad coalition of companies that are working on this together, and early access customers that are all building out this capability. Now, to that end, this is more than just, like I said, an NI thing. This is a broad coalition. For example, this is something that's being built into the IEEE 802.1 standard as a part of the standard Ethernet protocol. It allows you to have this deterministic real-time communication, converge all of your traffic, and all of your devices have this known sense of time. And when I say devices, that includes processor and FPGA. So you have this known sense of time across the network. And all of this is in the standards, although some of it is still in draft form. So let me tell you how this changes the way we do industrial networks. Right? So this is a good graphic. Here on the side is kind of the traditional approach to networking devices together, say in a plant. First of all, there's the internet, big bad internet, behind a firewall. You want to stay away from that. And anything you have to communicate across usually has to go through a fairly rigorous set of regulation and IT integration. You then have your applications which users can use, which communicate with gateway devices, which then connect to the sensors or actuators of the devices that are out in the environment, or other process elements. But in essence, these are separate layers that have a very specific communication between them, but overall they are non-transparent. So a device down here doesn't really have any access all the way at the top or at the user application. There's this regimented layer setup. Now this is challenging as we move more towards this industrial Internet of Things, where all of these devices are communicating together. You want to communicate across sites. You want to communicate through the cloud. And so what you need is a protocol that can be converged with other communication, that can have visibility from the top all the way down to the devices. And that's what this time-sensitive networking is focused on and is going to unlock for us. So it's very exciting. Are there any questions? It's kind of a very high-level view of what this is all about. Yeah?
You said it's going to be Q3. Does it mean PSN or the early access?
The early access. So the question is, it says release Q3. Does that mean this whole capability or just this early access program? It's just the early access capability.
So, very specifically, there's two CRIOs as well as software to support those. So you still use the Cisco switch, so the early access program is really access to that hardware and software so you can actually do this.
Yeah. So it's a good point in the fact that it's a limited set of hardware, software capability, but you can build a complete solution out of it. Yeah. So that's a good question. Is it the only additional hardware is the Cisco switch? Well, as Rudy said, there are two specific compact radios that support this, two variants that you have to have. So already you have a limited set of hardware. And then while this is a standard, right, 802.11 standard, it is something that silicon vendors and switch vendors have to actually build into their hardware. And currently, Cisco's done that for a couple of switches, and that's what we're showing back on that side. That's what's available. But there's some hope. There's a plan that this is going to become more broadly available across some of those switches.
To be clear, the compact radios that we're releasing, they are release ready. They're actually deployable as the 35 and 39. They're very close to ports. They're actually a superset of that capability. So if you're looking, it's a bit before you can get that PSN capable. So those are not made up hardware. That is actually proper hardware. On the Cisco side, again, the actual industrial switch that's up there is actually what they've already released. What they've got is native firmware that is supporting the PSN capability. So that's why it's still early access, because not all of the ecosystem is quite there in place. But on the NI side, our hardware is on first.
Cool. Yes.
And the combination of the
So the question is a little bit more information on the application areas and industries that this is targeted towards. So this has fairly broad appeal, but a couple of areas that we've been focused on is some of the more distributed applications that you end up with in, say, machine control. So anywhere where you're needing to do both input-output control. It also has value for data acquisition, but this first kind of real key application space would be if I want to close the loop across multiple network devices, reading and writing to sensors and actuators in multiple places. Anywhere where this unified sense of time would be valuable. Right? I can actually know the measurement taken here is synchronized with the measurement in the information. Okay. Yes?
The next slide has IIoT. Oh,
This one.
yes.
Yeah.
What is that?
What is that acronym? How many people know about the Internet of Things? Have you heard of that? I mean, this is somewhat in the zeitgeist, right? The Internet of Things is the way your Nest thermostat talks to your cell phone. The industrial Internet of Things is specific to the factory, to the industrial applications, because those same trends are happening there, right? So every device is wanting to interconnect, and the sum of all those things is greater than the one. Dr. T often refers to cyber-physical systems. It's the same kind of concept in the movie. All right. Good. I'm going to move on, if that's it. But if you have any more questions, definitely come up. Folks in the room actually are pretty well placed for those discussions after the fact. Okay. So let's move on. Another industrial communication bus. How many folks in here have used the 9144 EtherCAT chassis? Excellent. Yeah, it's been a popular way to expand your C-Series capability on our controllers. And we've also been getting the feedback over the years that, hey, you released the one, you refreshed everything else in the platform, when are you going to get around to this 9144? And the answer is soon. Q1 2017 is when we're targeting a replacement. The 9145, here's the big benefits. It's going to have a larger FPGA. And it's going to be slightly shorter than the 9144. The user experience will be the same as the 9144, so the same I/O nodes, the same project design where it's going to automatically detect and you can drag over the software and use the programmatic API as well. Just like the current one, it will have a pair of Ethernet ports so you can daisy chain them across multiple. So, yes, the replacement is on the way. The one thing I will mention is different mounting holes, so this won't be a direct drop-in. You may have to adjust your mechanicals to fit it. Okay. So that's what I've got for controllers. Any other questions or anything that you didn't see that you want to have any more information about? Good. Okay. So let's talk about I/O. Now, in the last few years, our C-Series R&D team has been very busy. Since about 2014, we've been releasing double-digit number of C-Series modules every year. And 2015 was no different. All of these modules or variants of existing modules were released. And we can talk about these. We can you can come up and ask me more. These are all something that's been available for a while. I'll highlight a few items. A channel isolated thermocouple module, something that's been in request for a while, is now available. Higher speed universal module with LEMO connectors, another great option. Special module here that allows you to do high current input, so 20 amps or 50 amps of current measured directly with ring loads. And then we've also improved our industrial communications bus capability with two new industrial buses, HART and ASI. Now, those are specifically for compact radio only, which is called out here. Anything that says for compact radio would be just for compact radio. Now, in 2016, we plan to continue this cadence. And here's a look at the modules that we have either released or are soon to release. I'll talk about some of the specifics in just a minute. In fact, yeah, we'll talk about the specifics as we go. So quite a bit of investment in our I/O. We understand that I/O is kind of the gateway for you to be able to even do an application. You got to have the I/O first. So let's talk about a couple of these. First one is a new DSA input module. This is specifically focused towards audio production tests, so for the DAC use case. The advantage here is a very high dynamic range, really focused on bringing in audio signals into C-Series for measurement. And this is a dual to an audio out module that we also have. So the pair of them together make a complete audio production test solution in C-Series. We'll talk about the other one in a minute. So this is also a new module, not released yet, but should be coming out imminently. So we're working on it. Should be end of Q3, beginning of Q4. C-Series first digitizer, NI 9775. So what's great here is this is 20 times faster than any other C-Series module we have today. So the faster you go today is a megasample per second. Here you'll be able to do 20 megasamples per second per channel, 4 channels. But there's a catch. It's a store and forward architecture, like other digitizers. You'll be able to take the measurements, store them on the module, and then transfer them back to the chassis at a lower rate. And you can store about 100 milliseconds per channel at 20 megasamples. Of course, that amount of time will increase as you reduce your sample rate, or the number of channels. There's also a high resolution mode, which increases your signal-to-noise ratio, but cuts your bandwidth, cuts your sample rate. Or there's a low-speed streaming capability that allows you to, one, achieve the same rate that we have today, megasample per second per channel. Or you can turn off channels and get all the way up to a single, one channel, 4 megasamples per second, and that's streamed directly to the chassis, bypassing the store and forward. So you can get that kind of complete range of measurements, but only on a single channel. We think this module is going to have a lot of applications. I've heard a lot of customers interested in it. A good example where this has been talked about is in grid measurements. So if you wanted to, for example, determine exactly when a transmission line was struck by lightning, you would need a high bandwidth measurement, but only for a finite amount of time. And then you could, for example, measure when that occurs at 2 different locations and find out exactly where the fault happened on the transmission. Or if you wanted to get the waveform of something like a lightning strike, which of course is very fast, high-speed phenomena, this would be another great way to measure. Any questions on this one? I know it's a different type of module than we've ever had. We've never had a module in C-Series that stores data on the module and then passes it back to the user. All right, moving on. So I mentioned earlier the DSA input here, mini XLR jacks. Here's the other version of that DSA input that we'll be releasing in Q4 that has a set of BNC jacks on it. So we'll have multiple connectivity options. Here you're looking more at the low distortion, low noise, still a high dynamic range. We think this will be used for audio corrected tests as well as other applications because you have connectivity for IDPE sensors with this specific option. All right, so now some modules that are going to help kind of in, I guess we already have channel isolated modules. What we're doing here is adding density. This is something that's been brought up multiple times in the past. Today we only have a 4-channel isolated. This will just double that density. But you can get it in a 10-volt or a 60-volt range. So the 60-volt range would be a great fit for a lot of automotive applications in particular. Another interesting module that's improving what we have today is a new AC digital input. So those of you familiar with our platform, we have the 9435, which is used for AC and DC digital input. We've got feedback over the years that due to, A, the density of that module, which is only 4 channels each, and also the low signal switching threshold, that it's not ideal. And so this new AC digital input has on-off thresholds much more in line with the IEC standards. So we'll switch at anything above 74 volts. This is a great dual to the 9437, which is a digital version of the same thing. So now with both of them, you've got 8 channels of each with a more appropriate switching threshold. So what you use this for is to read, for example, in an industrial environment, you could just wire in, say, the input to a fan and see if the fan is on or off. Right? See if you've got 120 volts or not, or 240 volt signals there. Okay. Another area where we've gotten a lot of feedback, literally in the decade we've had Compact Radio, we've heard multiple times, all you have in thermocouple is bare wire. You have to actually just wire in bare wire. But a lot of people are buying sensors with mini TC jacks, cutting off the mini TC jack and then wiring it into the module. So here we're going to offer the mini TC connectivity directly in the module. So hopefully this is just a more convenient solution for your DAC applications. All right, so before I move on, I'll pause. Any questions on C-Series? Yes? Question is, does NI have any plans for a high-speed analog output module? What I can tell you is we have been doing research on the module, actually. if you want, we can talk more about it. Currently, nothing is in development, so I do not have any dates to share with you, but it's something that we have been researching. And I'd be happy to talk to you more about what you need. Now's kind of the right time. Yes, so we can talk more afterwards. But yes, we are working on some research there. Any other questions? Higher current DC input. So
Yes.
yeah. So and this is reading. What's the application?
Basically for some of the customers that are working on solar panels and inverters, sometimes they need higher current DC period, and we are looking quite on there. So
Okay.
higher current AC motors won't work.
Yeah. And I assume you looked at the 9225, or 27. I think it is. Yeah. Okay, interesting. No, there's nothing I learned about the moment for that, but that's good feedback. Any other questions? All right. Let's move on. So now moving into more motion control, I want to remind everybody about the soft motion drive interface. This was something released last year. We had a couple of partners who had developed interfaces, and what this is it's an API. We've opened up the ability to plug in a set of code into the soft motion capability so that you can interface with more than just the drives that NI offers. Right? So here's a list of the various vendors now who have soft motion drive plugins. And so this should allow you to implement a lot of new solutions using soft motion and NI products because you have a wider selection of drives to choose from. And you can also develop your own plugin if you like. It's fully documented. Or you can download these plugins from the LabVIEW tools. All right, so this is another exciting product I'm excited to share with you. This is a brand new product from NI called NI Remote I/O. This is what it looks like in a minute. And the idea here is to supplement C-Series with a product built for simple control and monitoring tasks. So the application that I'm imagining is useful here is if you've got a customer or an application where compact Rio or vision or motion or PXI is valuable to the customer, and you can sell them that. But they also have some other items, very simple, maybe push buttons, limit switches, something low speed that they also want to read. And potentially it's a challenge to sell C-Series for some of those things. And so that's what this is meant to do, is give you a way to compete with some of those low-cost I/O vendors, which we have seen paired with compact Rio and PXI in the past. Now we have a solution that you can offer, NI Remote I/O. And this has complete LabVIEW integration. It's built through the EtherCAT driver. So if you have NI EtherCAT driver 16.0, you have support for NI Remote I/O. Plug it in through a second Ethernet port. Any real-time target with 2 Ethernet ports will work. It automatically discovers all the modules attached. Basically, you have a bus coupler here, and then you have different modules. And in terms of modules, we have a wide range. Now, unfortunately, you probably can't read this, because I can barely read it. But our offering includes mostly digital, 24 volt, multiple densities in input and output. And we also have analog input for voltage and current, an output module for voltage and current, and a thermocouple input. And they're fairly versatile, wide or multiple ranges of analog inputs. The digitals can be used as counters. They have built-in filtering capabilities as well. So this should give you a nice option, and the price points, again, are specifically designed to compete against some of these low-cost vendors who have been coming into these accounts in the past. Any questions on this? It's definitely different.
Would it be like competing against the back off?
Yeah, the question is competing against like that company. And that's exactly right. Yeah. So I'll give you the other list of folks that I like to throw out as the kind of vendors that we want to compete with in this. Beckoff, Wago, Omron, Phoenix Contact, Allen Bradley, Siemens to some extent. All these vendors have some lower cost remote solution that you connect to a field bus. That's what this is for. All right. Now this should be releasing in October. So this is going to be coming out soon. We'll be giving you all kind of early preview. Okay. Let's move on, if there's any other questions there, to new high-performance embedded. So R series and FlexRio products specifically. First, I want to talk about a product that's recently released, the new PXI MIO R series. So this is a replacement for a previous generation of MIO R series cards. As such, you've got 8 analog ins and outs at 1 megasample per second each. 48 digital I/O, which is less than the product replacing. So take that in mind. It's not a kind of direct replacement. But these are much more flexible sets of AI and DO. So you've got multiple input ranges for the AI, and then your DIO, just like the previous all digital modules, allow you to select different logic levels for each connector bank. You also have access to DRAM directly on the module, so you can store data right on the FPGA to do high-speed processing. This is a great application, or a great product for high-speed analog control, say laser control, or hardware-in-the-loop testing, where you can do all of the control loop right in the FPGA. Also want to remind everybody about our investments in FlexRio. Continues to be a great solution for embedded applications using PXI controllers. You have a wide range of adapter modules you can place on the front end. Give you a lot of high performance analog in, out, and DIO. You have direct access to HDL, full MDK if you want to build your own modules. And of course, this gets the full PXI product capability in terms of controllers and connectivity. Let's talk about software. So that's what I've got for hardware. Any questions so far? That was all the hardware in this deck. No? Good. Anything you didn't see that you want to ask about? No? Awesome. Okay. So, just like every year, LabVIEW 2016 releases, and we also have brand new real-time FPGA modules. What are you going to get in these new modules? First of all, NIWeek real-time has had kernel upgrade. We like to keep current. It incorporates the latest security patches and bug fixes. We want to make sure we stay on top of that, since we know Linux does have vulnerabilities that have been exposed. So we're going to make sure we stay on top of it. We also have some new packages in the NI repository, including Blues package, great for Bluetooth devices. Brand new OpenCV, which is a vision library that's pretty common in the open source market. And then we've got a VNC server. And X11 VNC. So this is my favorite package actually, because you've got a, say, performance compact Rio with a display port. You can now basically get a remote desktop connection to the device, which purely from a management standpoint makes life a lot easier. Other than that, the Compile Cloud has had hardware upgrades, which should improve your compile times, and the Compile Cloud workers, so the software in the cloud, now caches the most commonly seen Xilinx IP right in the worker, so that again reduces your compile time. How many folks in here are using the Compile platform? If you haven't, definitely you go take a look at it. You get it with SSP, so you probably all have access to it. You can kick off multiple compiles at a time in the cloud, and it drastically reduces your compile time because you're using somebody else's very powerful hardware. So definitely take a look. Yes.
Is that true, or is that only true after recent upgrades? Because 6 months ago, a year ago, I was doing a number of cloud compiles that consistently ran 25 to 50% by keeping them on my machine and actually sending them to the cloud.
Wow. But, so let me see if I can summarize. Is this always true that it's faster, or is this something recently that we've done? Because at least 6 months ago, you were seeing that your computer was faster than the cloud.
Yes. And
yeah.
I know 2-3 years ago the cloud was consistently faster, but a year ago, give or take, the cloud was consistently slower.
Interesting. So it's not the feedback that I've heard, but that's interesting. I'd like to share that with a couple of other folks, see if they have feedback.
Okay.
I would have told you, I would have assumed that this has been improving. I know a year ago we had talked about some improvements there. Also, the little computer use. Maybe you got a really fancy computer.
I do run a higher end laptop, so it's heavy as heck.
Yeah.
If you have the latest, greatest PC, you can be faster on your local PC compared to the cloud. But one of the big issues was this cache, or this IP generation. instead. So this caching should help, because a lot of times that would take 10 or 15 minutes
Okay.
just for that.
Because what was weird was I was even compiling inside a VM
Mhm.
and still consistently beating the cloud.
Sure.
Yeah,
The multiple compile feature is nice on the cloud. If you have a couple different things you want to try out, you can pick up multiple compiles and finish.
I will say that's a good pro tip. I do that a lot when I'm compiling, is I'll kick off 3 or 4 different options, even though I know only one of them's going to work, but I can compile them in parallel, and I'll just take the one that works. So a little bit more information on the roadmap for LabVIEW real-time in the future. In 2017, we're going to be working on adding a new DDS security library. Anybody familiar with DDS? Excellent. So DDS is a great way to communicate between devices. Provides a fairly standard solution for communicating between networked, really not just LabVIEW computers, but a whole range of devices that support the DDS standard. It's going to be built by RTI, which has been working pretty hard on this and has been promoting it for a while already. Further kernel upgrades are on the way, and an upgrade to the Eclipse tools that we provide to include Eclipse Neon and the latest GCC compilers. So anybody who's doing C++, will see a bump in performance as well as capability. In terms of long-term, our plan is to do yearly updates to the kernel, to stay current, again, for security and bug fix purposes. We'll make sure we stay on the long-term support initiative and ensure that anything we're releasing, of course, keeps with the preempt RT patch set, which is a separate line. How many folks in here actually care about the kernel version in Linux RT? That's interesting. I asked the same question earlier. It's good to know. Probably not talk about it much in the future. Doesn't mean that we won't continue to do the upgrades. The support is important. All right, so another detail on Linux RT, we've invested a lot in this operating system since 2013, when our very first controller, that guy, came out with it. It's now available on pretty much every one of our embedded targets, with the exception of PXI, even that is about to change. But this is a massive amount of development effort for Nine, so we're investing a lot here. We think it has a lot of value. We hope that you will join us on this platform. Now, on the subject of PXI, really as a roadmap as a whole, you can see we've done a lot of investment over the last few years, every year adding additional features, new platforms that are supported in Linux RT, or new capabilities, for example, Wi-Fi in 2015. Starting in 2016, you'll see PXI starting to get some support, specifically for LabVIEW Communications 2.0. And then 2017 and 2018, PXI migration will continue. So it's on its way. Yes? Let me make sure I'm hearing you correctly. Is there a migration strategy for controllers that have already been sold? So I don't, first of all, I don't have the best information. I don't believe so. This would be something where the latest generation of controller would support it, would be my expectation. But to be honest with you, I'm not the expert. I could find out if it's important. Come by afterwards and give you some big experience. Stop that. All right, any other questions on Linux RT here? Okay, we have one more note here on Linux RT. I want to tell you about some work we've been doing in a collaborative project for real-time Linux, or RTL. So this is a community specifically built to promote and develop real-time Linux software and merge that into the mainline Linux kernel. What's interesting here is that it's a pretty broad coalition. It's actually founding member here is Google, but the gold members are ourselves and TI and OSALD. All of them, again, contributing to the source code, fixing bugs, and giving back to the community, hopefully trying to push this back into the Linux Foundation. So we are making some big investments in this OS and investments in the community. I think that will pay dividends for you as well as you start to use the ecosystem of Linux software that's out there. Okay, so here's another interesting bit of software that we're working on. How many folks have heard of Codesys? All right, more than the last room. Codesys is a software IDE from a German company named 3S. It is somewhat of a de facto standard for IEC 61131 languages. 61131 languages include things like ladder logic, functional text, structured block diagrams, the type of programming languages that are often required on PLCs. And this software package, turns out we've worked on it, and we can run Codesys applications on our compact reader controller, side by side with a real-time application accessing the FPGA. So what this allows you to do is if you have any applications or opportunities where your customer is making 61131 a requirement, you can now meet that requirement. So yes, that can be done. And I have this Codesys software which will allow you to program in 61131. And at least get you a seat at the table, where in the past this was often a lockout for a lot of different opportunities. Currently, this is on NILabs if you want to try it out. That's where the release is at the moment. But we are researching this further. I do not have a plan or a roadmap date for you for when this will release. But if you're interested, definitely come talk to me and we can talk a little bit more about it. This is definitely an area of research for us right now. Does anybody ever run into that kind of requirement, a 61131 language requirement? Okay, that's not periodically. Okay, well, are there any other questions about it? Let me know. So another quick reminder, new software suites coming out in 2016. This was released, I think, last year for the first time, where we had the embedded control and monitoring suite. This is the kind of single part number product that a customer can use to program all of our embedded devices. So one USB drive includes all the software you see here, as well as training and certification for customers. In 2016, we're adding the MathScript RT module and the Eclipse CC++ toolchain to the installer that the embedded control monitoring suite provides. All right, and that is it. If y'all have anything that you'd like to talk to me more about, I'll be up here. If there's anything that you didn't see that you want to know, hey, where did that go? Come talk to me and I can tell you more. Thank you very much for your time.